Okay, so let's get a crack on then. So, hi everyone, my name is Medin. I am the president of Bartram and London Psychiatry Society, and we are a student-run society at Bartram and London School of Medicine and Dentistry. And I'm really happy to be bringing you today the first of our two psychedelic talks. So today we're joined by Professor David Nutt, who will be giving his talk on will psychedelics have a role in the future of medicine. So Professor Nutt is a leading figure in psychedelic research in the UK. He is the chair in neuropsychopharmacology at Imperial College London and was also the president of the European College of Neuropsychopharmacology. In 2010, the Times Eureka Science magazine included him in the 100 most important figures in British science, and the only psychiatrist to do so. So just before we start, just to lay down a few ground rules. So firstly, please do keep your microphones off during the entirety of the event, unless told otherwise. However, you can put your webcams on if you do feel comfortable to do so. Also, please do tweet throughout the event, so you can use the hashtag #ChoosePsychiatry, and you can also tag us on Twitter. We are at BL_PsychSoc. So Professor Nutt will be taking questions after his talk. So you feel free throughout the talk to submit your questions into the chat function, and one of the committee members will be able to relay this to Professor Nutt as well. And I also encourage you to select speaker view during the Q&A so that you can see who's speaking as well. We will be sending out some feedback forms after the event, and you'll need to complete this in order to get a certificate for the event. And just one last thing before we start. So a huge thank you to Professor David Nutt for taking some time up tonight to speak to all of us. And also a special thank you to all the PsychSoc committee members, particularly Sean and Daniel, who have worked really hard and given up a lot of time to put this program together for you. So with that, I hope you do enjoy tonight's event. And I'll now pass it over to Professor David Nutt.
Well, thank you very much. It's great to be talking to so many of you tonight. And for those of you who can't stay for the whole 90 minutes, the answer is yes. They will have a future, certainly in psychiatry. Just to explain what a neuropsychopharmacologist is, I'm actually a psychiatrist by training, and most of my research career has involved studying the effects of drugs on the brain to probe brain function, and that's what neuropsychopharmacology is. So, and as I'll show you, a lot of our recent research has been around understanding what psychedelics do, and it's that understanding at the level of neuroscience that has opened the door to them being used therapeutically.
It's just that's calling.
All right, can I carry on? Yeah, good. So let's go back in history. We see that psychedelics have been a feature of human culture pretty much since the beginnings of culture. And here are a range of the different agents that have been used. Here's peyote, the mushroom that makes mescaline. Here's a form of magic mushrooms. Here's ayahuasca, DMT, being brewed up over fire in the Amazon. And it's a combination of two plants, one that has DMT, the other that has harmaline, which is a monoamine oxidase inhibitor that allows the DMT to get into the body without being broken down by the liver. So it gets into the brain, so you can drink it. Amanita muscaris, a GABAergic mushroom, psychedelic mushroom I won't talk about today, but I am researching it quite actively now. Morning glory, the seeds of which contain an ergot derivative, similar to the ergot products that come in this fungus that grows on cereals when they get dew on them. And the most important message for tonight, the most important image is this image here. This is a Greek vase. It's over 3,000 years old. And it shows a Greek noble person partaking of ergot and wine. And the Greeks had worked out that that was a very powerful combination for having interesting experiences. They called them the mysteries. And when the dew began to allow the ergot fungus to grow, the Greeks would move out of their city-states into the fields, and they'd have their parties. They'd have several weeks of celebration with music and poetry and psychedelic experiences from the ergot potentiated by the alcohol. And then they went back to the city-states and they did what we all know the Greeks to be very good at doing, like laying down philosophy and geometry and beautiful arts like this, and also, of course, developing the first principles of democracy. And I think it's reasonable to suppose that the experiences, the insights they got from the psychedelic ergot probably contributed to the very foundations of modern Western society, which we can trace back to the ancient Greeks. So psychedelics have had a huge impact on culture for millennia. And really, it's only Western culture in the last 50 years that has tried to eliminate them as a source of inspiration and insight. Beginnings of the modern science of psychedelics you can trace back to this man, William James, who's one of the founding fathers of psychology, certainly of experimental psychology. And he took nitrous oxide, he took mescaline, and then he wrote this: our normal waking consciousness is but one special type of consciousness. Whilst all about it, parted from it by the filmiest of screens, there lie potential forms of consciousness entirely different. And then I've highlighted the next sentence because I think this is one of the fundamental challenges to modern science. No account of the universe in its totality can be final. That leaves these disregarded. So William James threw down that gauntlet to scientists over 100 years ago. And me and my group, we picked it up and we're running with it. And certainly we haven't got complete answer, but we've certainly made a lot more progress than poor William could make, because in those days he didn't have the tools, and he said to regard them as the question, whether they are so discontinuous with ordinary consciousness. But we do have the tools, and those tools have shown us remarkable insights into the nature of consciousness. And the next major protagonist in terms of the philosophy of psychedelics was Aldous Huxley, and he famously took peyote, mescaline, had a remarkable mind-expanding experience, wrote about it in this book, The Doors of Perception. And I would say that those of you who want to be psychiatrists or psychologists, it's a must-read book, because it's the most beautifully graphic explanation of the nature of altered consciousness produced by psychedelics. And it gives insights into the nature of thinking in general. Why is it called The Doors of Perception? Because Huxley went back to the writings of William Blake. William Blake was an English painter, a mystic, a poet. He wrote the words to the song Jerusalem, the sort of English national anthem. But like many great artists, he could see things differently from others. And William Blake said this: if the doors of perception were cleansed, everything would appear to man as it is, infinite. For man has closed himself up till he sees all things through narrow chinks of his cavern. And Blake was essentially complaining about humanity failing to properly utilize the abilities of their mind. And as a result of his mind being opened by mescaline, Huxley came to this very interesting inference. He said, because mescaline has worked on my brain to open my mind, the brain must therefore be an instrument for focusing the mind. And this was truly one of the great insights in the history of neuroscience, because we now know he's right. But we know he's right because we've accumulated an enormous amount of data on how the brain works. It'd be really nice if everyone could turn off their microphones, please. It's quite distracting to talk when other people are talking. Oh, thank you. So let me explain why I say this. I'm going to use a visual system as the exemplar in this case. So as you almost certainly, all those of you who have got any neuroscience background know that the brain is not a camera. It doesn't take a picture of what's out there. What we see, what our brain sees, is reconstructed from the electrical impulses that the photons from the external image produce in terms of changed alterations in activity of retinal cells, which send their signals up the optic nerve and into different parts of the visual cortex. And the visual cortex occupies about 20% of the whole of the cortex. And different parts of the visual cortex are responsible for different elements of vision. So the brain reconstructs what is out there, what's going into the eye, what the eye is seeing, but it does it in a very efficient way. It's far too inefficient to do real-time reconstruction of everything you see. So the brain relies on the fact that you can predict pretty much that what you see now was what you saw 100 milliseconds ago and 200 milliseconds ago. So the brain essentially doesn't uprate everything it's seeing. It just assumes it's there until something changes. And when something moves or changes, then it upgrades what its assumptions are. So the brain is a reconstructing organ, and it's essentially a predictive organ. It predicts what's out there. And that's the most efficient way of minimizing energy use. And that's kind of what Blake was saying. Blake was saying, basically, the brain makes you see as little as necessary in order to function in a way that gets you through life. But it doesn't, that is not enough to turn you into a great artist. So we essentially, all of us, almost all of us, see life in a very limited way. But even though we're looking through the chinks of our cavern, for most of us, what's outside is actually quite pleasant. Here you see some blue sky and some white clouds. But for people with mental illness, such as depression, when they see the world, they don't see a nice, bright, cheerful place. They see a place which is grey and unpleasant and very downbeat. And of course, for people with addictions, when they see the world, they see cues that highlight their desire for their love objects, such as alcohol or heroin or cocaine. So the brain not only constrains what we see, but it also dictates to a significant extent what we look for and how we interpret what we see. Now, in terms of the research with psychedelics, the big breakthrough came with this drug LSD. So LSD is a diethyl amide derivative of the key components of the ergot fungus and the morning glory seeds, which produce psychedelic experiences. And it was invented by this man, Albert Hofmann, as a way of actually improving cognition through increasing blood flow in the brain. And it turned out it did very much more than that. And here's Albert at 100. He's sitting in his villa overlooking Lake Geneva. And he lived to 102. And he used LSD in low doses, quite often microdoses, to maintain wellness. You'd be interested to know that the first British person to take LSD was a psychiatrist. He was the professor of experimental psychiatry at the University of Birmingham, the first professor in the world of experimental psychiatry. And it was Joe Elkes. He went on to live to 103. So I'm fairly reassured that certainly taking part in experiments with LSD isn't going to shorten your life. Now, Hofmann was able to persuade the company he worked for, Sandow, that LSD was a revolution in understanding the brain, and they made it available to many scientists around the world. And these two scientists took it, and these are the two most important Nobel Prizes in medicine ever, probably. On the left is Crick, who got the Nobel Prize with Jim Watson for decoding DNA, working out it was a double helix. And the right-hand side is Carey Mullis. Now, you might not have heard of Carey Mullis, but you rely on Carey's work, as does anyone who does life science relies on it. So one of the COVID tests uses the PCR, and it was Carey that discovered PCR. And Mullis was a biochemist in California who was trying to work out how to get enough DNA so he could do biochemistry on it, and it was very difficult. And then one day, during one of the many LSD trips he took, and this was when the drug was legal, he saw the double helix opening itself up and replicating like a whole series of serpents. And serpentine images are quite common in psychedelic hallucinations. And he realized that's what he had to do. He had to make the molecule unravel and replicate. So he hunted around until he found an enzyme, polymerase, to do that, invented the PCR, and got the Nobel Prize. And he says, I wouldn't have got the Nobel Prize if I hadn't seen this opening up of the molecule, the replication of the strands like serpents under LSD. And Crick was different. Crick had solved the problem of the coding of life with Watson. And then he went on to help Sanger get 2 Nobel Prizes for how DNA goes to RNA and RNA goes to proteins. So by that point, he'd kind of done everything that anyone could have expected in terms of understanding life. And then he took LSD and he realized that understanding life was pretty trivial because they'd done it. But understanding the mind was actually considerably more difficult. And the rest of his life, he spent trying to understand the mind. And of course, he couldn't really make as much progress then in the 70s and 80s and 90s as we've done now because he didn't have the tools, but he made a good effort. And I think both of them would support this statement by Albert Einstein. No problem can be solved from the same level of consciousness that created it. And I think that's why psychedelics do have a peculiarly powerful ability, not just to help scientists see ways of solving problems, but also patients. So I mentioned already that Hoffman worked for Sandoz. Sandoz made LSD available as these 250 microgram tablets, and it was used widely in the 50s and 60s. And it was used for 4 reasons. It was used as a psychotomimetic. It was used to model psychosis in normal people. And in fact, LSD and psilocybin are probably the closest, those experiences are the closest we probably have of any drug effect to mimic schizophrenia. Not the same as schizophrenia. They don't cause auditory hallucinations, which is the cardinal feature of schizophrenia, but they do produce a lot of the other symptoms. And in fact, we're using that. I'm working with Professor Mittel at the Institute of Psychiatry to model psychosis in normal volunteers and then try different kinds of non-dopaminergic antipsychotics to see if we can modify that experience. And we've already shown that you can. And one of those treatments, which is a tyrosine kinase inhibitor, is going into the trial of first onset schizophrenia now. The second reason was self-experimentation by mental health professionals. And back in the 50s, it was quite common for junior psychiatrists to be given LSD early on in their career so that they knew what it was like to feel different, so they had more empathy and sympathy for patients who had altered mind states. And some of these will talk today. They remember vividly those experiences and they often found them very interesting and helpful in their professional career. And then it was used for psychotherapy. And there were 2 kinds of psychotherapy. There was psychedelic psychotherapy, which is a single high dose, which produces peak experience, sometimes a mystical experience. It was favored in the US. And this is what we do today. When I talk about our research, we're using those a single high dose to produce a profound alteration in the person's understanding of themselves. And then there was psycholytic psychotherapy that was favored in Britain. And that was using a lower dose, a non-hallucinogenic dose, say 10 micrograms, 20 micrograms of LSD to loosen people's resistance, to break down some of their psychological barriers so that they could better engage in psychotherapy, which of course at the time was largely psychoanalysis. And this man here is Stanislav Grof, who's one of the great pioneers of psychedelic research for therapy and who carried on doing it even when the drugs were banned. And Stan said this: psychedelics used responsibly and with proper caution would be for psychiatry what the microscope is for biology and medicine, or the telescope is for astronomy. And that's unquestionably true. So why don't we use them? Why aren't they routine part of medical practice today? And the answer is because they got banned. And why did they get banned? They got banned because the CIA were worried that young American men were refusing to fight in Vietnam. And they blamed LSD for this. But in fact, the young American men were refusing to fight in Vietnam because they realized it was a completely stupid war. And they read the accounts of people like Ron Kovic, who's filmed The Born on the 4th of July, hopefully you've all seen, the story of someone who comes back with their spinal lesion as a result of fighting. And Ron Kovic said this: all I could feel was the worthlessness of right here in this place and this moment, all for nothing. And Michael O'Brien said, I didn't want to die, not ever, but certainly not then, not there, not in the wrong war. The people fighting in Vietnam were coming home and saying, this is a crazy war. So young people didn't want to go and fight there. Why would you go and fight a war? At 18, you were being selected randomly on the basis of whether your birthday ended in an odd or an even number to fight a war you didn't understand in a country you'd never heard of, to an enemy you never saw in the jungles. And people didn't want to do that. They thought it was futile. And an anti-war movement was developing. And the anti-war movement became associated with LSD because quite a few people escaped the draft and they went to San Francisco, Haight-Ashbury. They took LSD, they listened to the Grateful Dead, they put flowers in their hair and they protested the war. They became supposed followers of Timothy Leary there in the middle, who said, turn on, tune in, drop out. But the most important image on this page is actually the one on the right, because that is an anti-war protest. Drop acid, not bombs. And of course, no governments have ever heeded this, but I think, frankly, that's a message that might well have been heeded. If it had been heeded in the last decade, maybe we wouldn't be dropping bombs in Iraq and in Syria, and maybe we wouldn't have 5 million homeless refugees destabilizing the whole of Western Europe. But we don't, because we still believe that dropping bombs is more important than negotiation or thinking differently. But at the time, acid was seen as the key driver of the anti-war movement, which of course it wasn't, but it was something that could be attacked. The anti-war movement couldn't be attacked, but acid could. But in those days, in America and in Britain, you couldn't ban a drug just because you wanted to. You had to find some excuse, some rationale for banning it. You had to find some evidence of harm. And it was very difficult to find evidence of harm from LSD. So they created evidence. And here are the scurrilous, the rags, the completely fictitious accounts of LSD harms that were promoted on the front pages of these different weekly magazines. And you can see it's a classic feature of these magazines. You've got semi-naked women and you've got people having sex or talking about sex. And you've also got animals. A girl gives birth to a frog. Of course, it's all completely fictitious. It's all made up. But the argument goes, and the same as in Britain as in America, if the editors of these newspapers are sufficiently concerned to put these stories front page, then that's concern enough to get the drug banned. And it was banned. And remarkably, even more perhaps, is it was banned in the face of opposition from the most powerful man in the world, and certainly the most powerful man in America, Bobby Kennedy. He was Secretary of State to Johnson, and he would have been president if he hadn't been assassinated. And he's saying to his bureaucrats, why, if clinical LSD projects were worthwhile 6 months ago, which they were being funded, why aren't they worthwhile now? You keep on going around and around. If I could get a flat answer about that, I'd be happy. Is there a misunderstanding about my question? I think perhaps we've lost sight of the fact that LSD can be very, very helpful in our society if used properly. Why did he say that? Because his wife was having LSD therapy for her depression, and Cary Grant was in the process of having up to 100 separate LSD sessions for the trauma of being basically left neglected by both his mother and his father as a kid. So LSD was seen as a solution to a great number of psychological problems. But despite that, despite the medical profession supporting it, it got banned. And that's unfortunately just the nature of the controls which we still have today in terms of drugs. That basically all authorities can do is ban them. They don't have any other more subtle approaches. And I'm going to argue to you that that's the worst censorship. That ban on psychedelics is the worst censorship of research in the history of the world. It was initiated in 1967, validated in the UN 1971 convention, and it exists today in every country in the world that has signed up to the UN Drug Convention, 227 countries. there is no other example of censorship that has been so pervasive. The best example I can come up with, well, it was a rather long time ago. You've got to go to 1616, when the Papal Congregation of the Index, i.e. the Pope or the Catholic Church, banned all books that talked about the writings of Copernicus. Now, as you all know, Nicholas Copernicus was an astronomer who discovered that the Earth was not the center of the universe, the sun was. So that conflicted with the Catholic teaching. And so they banned his books. They executed Giordano Bruno, who talked about and promoted the concept of the sun being the center. They threatened Galileo with execution if he carried on saying the same. And that ban lasted 150 years, but it wasn't universal, it wasn't global, because it was only where the Catholic Church had held sway. And the Northern European Protestant astronomers could carry on looking at the sky and talking about Copernicus with impunity. And to be fair, at that time, there weren't that many astronomers. The ban on psychedelics has lasted for over 50 years. And over the last 50 years, hundreds of thousands of neuroscientists and clinicians have been denied the opportunity to study these drugs. And that's why I say it's the worst censorship of research ever. And here is data I will show to prove that the conventions destroyed research. So what you see here, the blue bars are the number of publications per year for LSD, and the red for psilocybin. And here's the convention in 71. And you can see after the convention, research output fell dramatically. And the reasons for that are twofold. The first is the US government, which had funded most of this research, ceased to fund any. And without funding, it's actually quite difficult to do research. Even though they say it wasn't illegal to do research, you were in theory allowed to do research on LSD, no one was able to, because A, they couldn't get funding. And even if they could get funding, they couldn't get the drugs, because the Drug Enforcement Agency in the States, the Home Office in Britain, effectively blocked access to the drugs, even if you had permission to do the research. If you're interested in the history and the politics of this, I've written a couple of papers about it. This one is I've got a detailed one covering many drugs, including cannabis and ketamine. This one focuses more just on the psychedelics. Now I want to tell you how we've been fighting back. We started fighting back about 15 years ago. This young man, Robin Carhart Harris, came to me and asked if he could do a PhD with me. And I accepted him in. And Amanda Fielding, who set up the Beckley Foundation, was interested in asking the question, what do psychedelic drugs do in the brain? And I was interested in answering that question. And we decided for our first experiments to use psilocybin. So this is the active ingredient of magic mushrooms. Here's a magic mushroom species. It grows in Britain. It's called Liberty Cap, very familiar to many of you. And the active ingredient, psilocybin, has quite high affinity for the 5-HT2A receptor. In fact, all the serotonergic hallucinogens work on the 2A receptor. LSD has very high affinity, and it's the most potent in man. Psilocybin has quite high affinity, it's next potent. Here's mescaline. Mescaline has low affinity, much less potent. So you give micrograms of LSD, milligrams, low milligrams of psilocybin, and hundreds of milligrams of mescaline. But they all work on the 2A receptor. And this receptor is very interesting because this receptor is hugely expressed in cerebral cortex. And it's particularly expressed in those areas of the cortex which integrate cortical function. The human brain has more of these receptors than any other animal's brain. And there are people that believe, and it's not implausible, that these receptors are the receptors that not only drive human consciousness and human cognition, particularly the sort of abstract cognition, but also may have helped drive the massive expansion of the human brain, which distinguishes us from all other animals, and particularly other primates. And these serotonergic 5-HT2A receptors, they're particularly expressed on these neurons here, the layer 5 neurons of the cortex. And I'll just give you a very brief, simple summary of actually how the brain works. The brain is a kind of two-dimensional computer, or actually a series of linked two-dimensional computers. So the primary computing is done in these neurons here, which are in what we call cortical columns. A whole cluster of neurons is like a little computer, and there's 160 billion of these pyramidal cells in the brain, and they make you can almost see each one as a little computer. And so they do the primary processing in this axis, which is orthogonal to the cortex. But then the cross-cortical communication is done by these neurons. So they take the information from these computers and they turn it into, add it to the whole brain, which then becomes a supercomputer. And these neurons have a lot of these receptors, and if you stimulate these neurons, they fire like crazy. In fact, they fire like so crazy, they have their own special set of GABA interneurons to prevent them going so crazy, because if they go too crazy, you can have problems in actually even having any kind of brain function. But the key thing is that these neurons regulate cortical integration, and that's fundamental to the understanding of psychedelics. So the first experiment we did was we put people in a scanner, we gave them psilocybin, we gave them intravenously because we couldn't afford to buy enough of it to give it orally, and it's 10 times more potent if you give it intravenously. And people had the classic experiences that they saw hallucinations, their body morphed, they felt that their ego was dissolving. Some people floated outside the scanner. One went to the foot of God and bowed there. Thankfully, he came back so we could complete the experiment. And in the end, we did the analysis. We did ASL, alternative spin labeling analysis. And to our amazement, we didn't see any increases in activity in the brain at all. We just saw decreases. But in the posterior cingulate, the anterior cingulate, and the thalamus, where there are no receptors, 5-HT2A receptors. And we think that's a secondary effect of these changes in the cingulate cortex. We thought that was so weird. We repeated it using the different technique, the bold technique, and we got the same results. And we realized that Timothy Leary was wrong. That actually these drugs don't turn on the brain, they turn off the brain. And then the question became, how does turning off the brain lead to the psychedelic experience? Well, here you see the magnitude of reducing cerebral blood flow predicts the subjective effects. So we've got a very clear relationship. Turning off the anterior cingulate cortex is associated with powerful psychedelic effects. What's going on? Well, at that time, the construct was developing that there were, or the connectome of the human brain was being explored and defined. And the idea that there were two fundamental hubs in the brain was being developed. And those were called the connector hubs. And this is the anterior connector hub. And here's the posterior connector hub. And the anterior connector hub is this part of the brain which we showed, anterior part dampened down by psilocybin. And this connects your planning, your executive function with your emotions and your memory. And this is very much where you and your memories and your access to all your past and present and future hopes are encoded or regulated. And the posterior connector hub is the posterior cingulate cortex, and that coordinates basically all your senses, your hearing, your vision, your proprioception, your touch, your smell, etc. And we realized that these two, by switching off these two regions, we were disorganizing the connectome. And the analogy I use is like an orchestra. The brain essentially has two conductors, the anterior and the posterior conductor. And just as if you take a conductor away from an orchestra, it might decide it doesn't want to play Mozart. It might want to play its own tunes. It might want to do jazz. When you take away the conductors of the brain's orchestra, the brain then does its own thing. It becomes free. And that's how the mind gets opened, as according to the idea of the vision, effectively, of Aldous Huxley. These drugs open the mind because they take away the ability of the brain to orchestrate, to focus, to control the mind. So it was extremely pleasant for us to have kind of proved Huxley's insight correct. Let me just talk you through it, because there's one other interesting twist on this, which I find peculiarly intriguing. So let's go back. Remember I told you about the visual system, the photons go into the retina turns them into electrical impulses, got the optic nerve into the brain reconstructs. But when you stimulate those 5-HT2A receptors, it can't reconstruct properly because the reconstructive system, the cross connections between the different parts of the visual cortex are disrupted. So you can't put together the image that's out there. So what do you see? Well, quite often you see this. You see these what we call elemental hallucinations. And we know from electrical studies, like Hubel and Wiesel and other studies of how the primary visual cortex and the secondary visual cortex reconstructs the electrical impulses from the eye and the superior colliculus into images. They start by making simple shapes with simple colors and simple movement. So under psychedelics, you are able, for the first time in your knowing life, to see the primary workings of your visual cortex. And I think that's extremely cute. And the only other time in your life it's been like that was when you were a baby and you can't remember. And based on that, I've come up with the idea that there are at least two different forms of consciousness. It's supporting the idea of James. The normal awaking consciousness is driven by glutamate. More glutamate means you're more aroused, you've got better attention, you lay down memories. And it produces what I call parcellation, the amazing, peculiarly high quality of parcellation, the ability of our brains to see in minute detail things we see, things we hear, things we think, the precision of our brains in terms of differentiating all the 26 letters of the alphabet, etc. The brain is a parcellating machine, and that's driven by glutamate and balanced out by GABA. But on the other axis is the 5-HT2A stimulation axis, and that produces a very different, produces a psychedelic state. Now that intersects with the normal state, and that's important because people can remember, usually for the rest of their lives, some of their very early trips. But the content is different, and the focus is not on parcellation, but on integration. It's not on memory, but it's on meaning. And it's not on attention, it's on valence. And generally valence is positive, but sometimes with depressed people, it can be negative. So these are two separate intersecting elements or forms of consciousness mediated through different neurotransmitter systems. One of the things we discovered is when you have a new data set on a drug as interesting as psilocybin, biomathematicians are very interested in working with you. And we've worked with 3 different groups, and this one produced the best image, so I'm showing it to you now. It's almost become a meme for our work. And this is the work of Paul Expert at King's College. And these 2 images contain the same number of points. That basically, there's 7,200 points in each image, and these are correlations analyses. They basically correlate which bit of the brain change in relation to other bits of the brain. And on the normal left-hand state under placebo, or just as you're looking at me now, your brain is largely connected around the edge. That's called the small world concept of the brain. Basically, the visual cortex, or the visual cortex, auditory cortex, or auditory cortex. Of course, there's some cross-cortical connectivity. If you see a tiger, you've got to move your arms and legs to run away. But most of the work in the brain is around the edge. And that is why the brain is a very efficient organ, because it doesn't waste time doing a lot of cross connectivity. It doesn't need that connectivity to do all the routine things you're doing, like turning on the computer, listening to me, remembering what I'm doing. You don't need that's a process which has been well laid down over decades. And the psilocybin, the control centers which limit cross-cortical connectivity are broken down. So you get massive increases in connectivity. Bits of the brain that haven't talked to each other since you were a baby are now allowed to talk. And this increase in connectivity has 2 huge ramifications. The first is that people can see things that they've not seen before. They can think, they can remember things that they've done. They can see behaviors. They can see things that have happened to them that may have been repressed by their brain. They come back to the surface. And that can be very important in depressed people understanding why they're depressed, because often they've repressed it. And the second thing is that increased connectivity allows them to come up with new solutions to their problems and change. And there's a third twist to psychedelics, which is that the change, because of the 5-HT2 receptor is particularly involved in neuroplasticity and learning, the changes can actually end up being relatively long lasting. So you can improve your ability to cope with life through the insights and changed behaviors which can be ingrained. And after all those experiments with psilocybin, we went on to do one with LSD to see if it was the same, and it was. And this is a beautiful example of the small world when you're looking at visual system. So in the normal state, you close your eyes, and the only bit of your visual cortex that's doing anything is V1 and a little bit of V2, and a tiny crosstalk to the hippocampus, which is regulating some of the memories you'll see. But under psychedelics, when you close your eyes, you get vivid, fantastic images like super dreams. And that's because the visual cortex is connected to everywhere. And the brain has become this fascinating, buzzing mass of crosstalk. And that's why you get not just fantastic visual hallucinations, but massive insight, massive reconstructions of memory. And also you can get phenomena like synesthesia, where you can see colors or hear touch, etc. Getting this stuff published was not easy. Referees said, well, it's all just blood flow changes from 5-HT receptors on blood vessels. Well, it couldn't be that, because those receptors are all over the brain. Then our changes were very localized. What do you expect if you mess with the brain with psychedelics? Well, I would expect slightly better refereeing from these supposed top neuroscientists who are rejecting our papers. And then I read this quote by Huxley and realized what it was all about. He wasn't quoting, this quote's not about science, it's actually about politics. But it's absolutely relevant to science. And those of you who want to be scientists or even clinical doctors should write this down and stick it above your desk. Orthodoxy is the die-hard of the world of thought. It learns not, neither can it forget. And so much of science is prosecuting and purveying the orthodox view. And that is very often wrong. And certainly psychedelics have shown us that our predictions of the brain are completely wrong. We thought they would turn on the brain. They actually don't. But we took on the challenge of these referees who said it's all blood flow changes. We measured brain activity under psilocybin and under LSD using magnetoencephalography, which measures electrical activity in the brain through the magnetic dipoles it produces. And we found the same thing. We found that those regions of posterior and anterior cingulate cortex were the targets of psychedelics. And these images look at a disruption of normal brain oscillatory activity produced by psilocybin. And this is the brain getting colder and colder. You're completely switching off the normal, you're reducing the power of oscillations in these frequencies to a very low level. You're switching off basically those parts of the brain. And as I say, the posterior cingulate, that's the part of the brain which determines how you perceive yourself in space, which is why people get this sense of floating out of the scanner, etc. And I'm really a great fan of MEG because you can get these kind of brain prints, which are like fingerprints of drugs. And on the right-hand side here, you see LSD and psilocybin, and blue means reduced power. The synchronicity of the brain is massively disrupted. And this is what we call the entropic brain. It's a brain with very little synchronous activity, a lot of random activity, which allows this massive connectivity. Over here, you have GABA drugs. When you enhance GABA, you put the brain into a state of increased synchronicity, which eventually, in this particular drug, propofol, turns you into comatose. You become anesthetized. The more synchronicity you have, the more synchronous brain activity, the less you learn, the less you think. And when we did this experiment, several of our subjects became completely cataplectic. They couldn't move and they couldn't think because their brains had locked into this peculiar state of super connected, very high frequency, powerful, very powerful low frequency waves, like a kind of living anesthesia. And in between, here's the drug that, of course, you're almost familiar with, is alcohol, which is a kind of GABA sedative with a little bit of glutamatergic activity, very different from psychedelics. And here's ketamine. Ketamine is an anesthetic that works differently from the propofol. It's not sedating. And it disrupts cortical function very similarly to the psychedelics. And that's why you get often quite similar reports of very altered states of consciousness, and also probably why this drug is also now being developed to treat depression. So why did we move on to treat depression from this psychedelic research? And I want to say clearly at the beginning, when I started out working with studying psychedelics, I had no inkling I would be using them to treat depression. I had no idea they might even work for depression. It was the imaging studies which led me to think that they might be antidepressant. And as I'll show you, we were right. So why is depression important? Well, it's the #1 cause of disability in the Western world. Treatments fail in about 1/3, and it's increasing prevalence in young people, particularly with COVID and lockdown. So 2 things we saw in the psilocybin imaging work that made me think about depression. The first was this image, which I've shown you before. This is the bold image showing the suppression of activity in the anterior cingulate region. This particular part of the anterior cingulate is called the subgenual or medial prefrontal cortex. And we know that all these different treatments of depression attenuate activity in this region. So if SSRIs get you better, or CBT gets you better, or sleep deprivation, or ECT, even placebo, you get better on placebo, this activity in this region goes down. And the reason for that is that this region is one of the driving centers for depression. It actually drives the negative mood. So you've got to suppress it. It's overactive in depression. You suppress it with these antidepressant treatments. So we thought, well, if psilocybin switches it off, maybe it will be an antidepressant. The other reason was that at about the same time we were doing this work, the concept of the default mode network was developing. And this is a network which is only been discovered as a result of brain imaging, because it's not obviously connected. It's medial prefrontal anterior cingulate, posterior cingulate, and these 2 lateral parietal regions. And these work in unison, and it's called the default mode because it's the area that is active when you're not doing things. So to show the default mode being active, we just do a very simple thing. We put people in the scanner and say, close your eyes and stay still. And then they start to think. And when they do that, the default mode network lights up. And because they're lying still, the sensory motor cortex is not lit up, and the visual cortex is not lit up because they close their eyes. So this is the network which encodes your sense of self. It would, if you're a Freudian, it encodes your sense of ego. And it's where you do your thinking about your present, your past, and your future. And psilocybin completely disrupts that. This is a seed region showing which we use to produce these connectivity images. Under psilocybin, the default mode disappears. In fact, it becomes anti-correlated with the frontal cortex. And that is why people feel that they don't have an ego, why they feel that they're floating out in the scanner, etc. What's that got to do with depression? Well, it turns out about the same time as we were doing this work, this group in France were looking at the default mode in depression. So here's the default mode in non-depressed people, and here's in depressed people. And you can see, obviously, a lot more of the brain is connected, working synchronicity, in synchrony in people with major depression. And that explains several things. It actually explains why depressed people have poor cognitive function, because they don't have so much particularly prefrontal activity to do executive tasks. Also explains why they're tired all the time. They're actually munching up a lot more energy by keeping this network over engaged. What drives that? Well, this subgenual region here, that's overactive, and that drives this overactivity. But what's particularly intriguing is that this overactivity predicts rumination. The greater the overactivity in the default mode, the greater the rumination. And that makes perfect sense, because depression is a disorder in which people ruminate. They continuously think about themselves, about errors they've made, mistakes they've made. They have guilty thoughts. They can't break out of this, in what we call internalized thinking. It's an internalizing disorder. They think about themselves in this very negative way. So we thought, well, we know how to break down this default mode overactivity. We'll give them psilocybin. We'll just fragment it. And we did. The other reason we thought this was likely to work was because some of our volunteers, even when they're given psilocybin in a scanner, said that they felt better afterwards. And they often said that the improved mood was quite enduring. And just before we started, this group in Johns Hopkins had taken normal middle-aged volunteers and given them a 25 milligram dose of psilocybin, the same doses we used, in a psychotherapeutic setting. You can see that here. There's a therapist on the right, Bill Richards. And that many of these people said that the psilocybin was a very meaningful experience. And 2/3 said it was one of the 5 most meaningful life experiences they'd ever had, which is quite intriguing, isn't it, for sort of middle-aged people to still have the opportunity for something as powerful as that. And many of them said that the effects that led to well-being, the insights, improved their sense of value in life. And many of them said the effects endured for many years. So we thought it was quite likely that there might be a positive effect if we gave it to depressed people. And surprisingly, in 2012, we got a grant from the MRC. It's the only money we've ever gotten from the government or the Wellcome Trust to do this research. They gave it to us because depression was then, and it still is, a major, major problem, and treatments are not good. But getting the money was the easy bit. It took 3 iterations to get ethical permission to do this. And the ethics committee would say, well, it's too dangerous. And I'd say, well, the MHRA have said it's not. And they say, yeah, but how do we know that depressed people won't have a very bad reaction? And I said, well, we're going to monitor them and protect them if they do, because we'll have 2 therapists. And they said, yeah, but how do you know it's safe? And I said, well, look, we know 1 million people a year take mushrooms in Britain, and no one's ever died. It's very safe. And the MHRA have said it's safe enough to use. And they said, yeah, but you can't prove that's true in depressed people. And I said, well, I think quite a lot of the people who take magic mushrooms probably were depressed at the time because it's such a common disorder. And they said, no, you cannot do a controlled trial. You have to do a safety study. You can give it to depressed people. You can give it to 12 depressed people and monitor them for a total of 6 months. And if no one dies, then you can go and do a controlled trial. Well, we had to say yes, because that's if the ethics committee say that's what you've got to do, you've got to do. So the actual study wasn't a study of depression. It was a study of whether psilocybin was dangerous. But of course, the secondary measures were those of mood. But anyway, that was easy. Getting the drug was difficult. Only one place in the world would make it to the standards we needed, the quality manufacturing standards. It took 30 months to get this because it's a controlled drug. And you have to have special licenses to make it and to import it, export it, etc. And 2 more months to get approvals from the regulators. And then we started. And I worked out it cost about £1,500 a dose, which is rather excessive for a drug that comes from mushrooms that grow in my garden and on many hills around Britain. And when I talked to the government about this, I said, look, this is ridiculous. The rules you've put in place make it almost impossible to research this agent. I have to have a special safe with a camera to make sure I'm not stealing the stuff or other people aren't stealing it. Why do I need this? I say to them, and they say, well, this is a dangerous drug, a Schedule 1 drug. You might be selling it. And I say, I think at £1,500 a dose, I'm going to struggle to find any buyers, even in Chelsea. But the rules are the rules, and I have to keep this. I can keep my heroin in a normal safe, but I have to have a special safe for the psilocybin. Well, we did the study, the feasibility study of 12, the safety study. We gave them a low dose to start with to make sure they didn't have bad reactions. None did. And then we gave them the high dose, the 25 milligram dose a week later. And the effects were absolutely amazing. So these patients were treatment-resistant patients. They'd all failed on at least 2 antidepressants. Some had failed on 10 or more. They'd all failed on CBT. And they all got better. And half of them were cured. They were completely in full remission within a week. And some of them are still cured 6, 7 years on. Most are not. Most have relapsed. So the 2 important things here. The first is, this is the most powerful impact of a single treatment in resistant depression there's ever been. And the second is that it tells us that depression is a nasty disorder. Even when you can get people better, it still comes back. It's like a cancer growing in your brain. And that's perhaps not surprising because many of these people have been depressed for 30 years. So getting rid of something that's as ingrained and has been repetitively controlling thinking for so long, maybe it may need more than one treatment. But what's particularly problematic and sad is that some of these patients, this one here, completely normal, back to normal. 3 months later, he's slipping back. Now he's up here, but we cannot treat him again. This drug's illegal. He cannot have it except in a clinical trial. I'm not allowed to do clinical trials on people who've had it before. So it's a catch-22, and it's peculiarly distressing to him and me that we know he can get better and we can't do it. Because there's this fear that this drug will be dangerous to people who use it recreationally, when it's not. And even if it was, that's no reason not to give it to people with depression who need it. After the first 12, we got permission to do another 8. So we had 20 subjects for our imaging work. And this is the total sum of the data. And you see here, so here are the change scores in depression. This is a self-rated inventory of depression. 50% reductions in depression scores up to 5 weeks. These are the effect size, Cohen's D of 2.3. You see massive, massive effect size. Even at 6 months, people are still significantly better, but it's slipping away. Now, since then, there have been several controlled trials for depression and anxiety associated with people with end-of-life diagnosis, people who have been told they've got cancer or some other terminal illness. And we know that psychedelics can be very helpful in preparing people, allowing people to come to terms with death. And that's because the psychedelic experiences makes you realize that actually, you are in many ways a combination of atoms, and those atoms are permanent. They've been there since the Big Bang. So you don't actually die, you just change into a different form. And now there's a multi-center study in Europe run by Compass Pathways. Now, where's it going next? Why do I think these drugs will be the future of psychiatry treatments in many different areas? And they'll also have an effect in neurology as well, but I haven't got time to go into that. But there have been open trials showing it can help people stop, psilocybin can stop people smoking, can stop people drinking. We're teeing up to do studies in anorexia and OCD and hopefully with heroin addiction as well. And you might say, well, that's weird. What's tobacco dependence got to do with OCD or depression? And the answer is they're all disorders in which people's thought processes become over-engaged with objects they don't want to think about. So smokers don't want to think about tobacco, but they can't stop. Depressed people don't want to think guilty thoughts, but they can't stop. Alcoholics can't stop thinking about alcohol. And these internalizing disorders, we think that the thought processes should be able to be fragmented by the fragmentation of the default mode with psilocybin. And also there's studies going on with ketamine and also MDMA, and I'll talk about that in a minute. So psilocybin is one of the future planks of psychiatry, and the other one is MDMA. Here's the cover of the British Journal of Psychiatry, an editorial that Ben Sessa and I wrote a few years ago. This man is Sasha Shulgin, a chemist who rediscovered MDMA. He was testing a whole range of different stimulants because he was making them as a standard for the Drug Enforcement Agency in the States testing facilities. So when they found someone with a white powder, they could find out from his standards what it was. Like all good chemists, he tested it on himself and said it had a peculiar effect, very different from any other stimulant or psychedelic. It produced a clarity of thinking that was really rather unusual, but also a great feeling of empathy. He gave it to his wife, who was a psychotherapist. She said, this is amazing. This drug will revolutionize psychotherapy, particularly for couples who have basically fallen out of love and for where the sort of normal grating experiences of married life or togetherness slowly build up and gradually drive you apart. And she used it, as did many therapists in the West Coast of the States, to help people fall back in love, to get back together. And it was very powerful and effective treatment. It was called empathy. And then some commercial people decided they were looking for a synthetic legal stimulant so that people could not have to use coke or amphetamine. They started using ecstasy and related drugs. And to sell it, to improve its cachet, they changed its name from empathy to ecstasy, and it became the drug par excellence of raves. And because its name was changed, because raves were big groups of young people, that scared the authorities. They thought that the LSD experience was coming back. People were going to change and start voting against the conservatives in power. And so they decided to ban it, and it was banned. And it was banned in the same way as LSD was banned. It was banned by generating hysteria about its harms, by creating lots of basically dishonest science about its harms, but it was banned. And the last 10 years, though, we've been fighting back. Up to 10 years ago, if you went to a conference and we talked about ecstasy, all the people were talking about was how ecstasy caused brain damage. It doesn't, but people wanted it to, and so they generated data that said it did. Now, you go to a conference on MDMA, we talk about how it heals the brain. And that sea change has come from the wars in Iraq and Afghanistan and the vast numbers of veterans who are suffering from PTSD. And also, of course, the war in Syria, where vast numbers of civilians are suffering from PTSD. This is Aleppo. It is hard to imagine that anyone who's lived in Aleppo can't have at least some serious kind of emotional trauma. And the landmark breakthrough was this study by the Mithoffers. And they took people with PTSD who'd failed treatments on SSRIs, they'd failed on psychotherapy, and they randomized them either to psychotherapy plus placebo or psychotherapy plus MDMA. And they found that 2 MDMA sessions, 125 milligrams, 2 weeks apart, basically healed all but one of them. And they all the ones that went into remission stayed in remission for years. This is the most powerful treatment for resistant PTSD there's ever been. And we were interested in that, and we wondered what MDMA did in the brain. And it was actually quite hard to get money to do this. In the end, this study was funded by Channel 4 TV, who wanted us to do it live on TV, and they gave us money to do a live study, so to show a few volunteers taking it live. It was the most downloaded Channel 4 science program ever, and the results were actually quite intriguing and unexpected. Just like with psilocybin and LSD, they didn't turn on the brain, they turned off the brain. MDMA turns off the brain. So it's quite interesting why it makes you dance all night. But anyway, we'll come back to that another time. But the areas of the brain it turns off are very different. It's not a psychedelic. It doesn't turn off the default mode. It actually turns off the amygdala and hippocampus. And I believe that there's that dampening down of those regions, which allows people with PTSD to benefit from MDMA, because the treatment for PTSD is exposure therapy. The problem with PTSD is that people can have the memory of the trauma triggered. So if you've been blown up, you might hear a car exhaust backfire, and then you think you're being blown up again. And it's not that you think you're being blown up again, it's actually you relive the experience of being blown up again with all the emotions that come from that. And that is very destabilizing. You just imagine if that happened to you as you're listening to my lecture, you wouldn't be able to sustain it. So the way we deal with PTSD is we get people to relive the emotions and the memory, and then hold the emotions for long enough till the brain gets bored of them, you extinguish, they fade away. But many people can't do that. They dissociate or they run out of the room. They can't sustain the therapy. But under MDMA, they can. MDMA suppresses the emotions enough so that you can hold them and then extinguish them. So we think that's why MDMA works. And then recently, in this date, I think this paper is coming out this week or next week, Ben Sessa, who's an addiction psychiatrist, reasoned that a lot of his adult alcoholics were drinking to dampen the pain and the memories of PTSD. So he said, well, maybe if we treated the PTSD emotions, they wouldn't need to drink. So he took 14 people who were severe alcoholics, he detoxified them, and then he put them through a 12-week course when they got 2 MDMA sessions, just like the PTSD study. And he looked at their drinking for the next 9 months. And the results were amazing. So I just want to be clear, these aren't parallel groups. The blue bars is an audit we did of our usual therapy, the 12-week therapy. People are drinking very heavily. This is the number of units a week, which is huge. And then they detox, so they're clean. And then they go through the therapy, and then they're followed up for the next 9 months. And you can see, basically, by 9 months, they're drinking as much as they were drinking before. Whereas the ones that had MDMA, they're drinking much, much less. It's the most powerful treatment intervention in alcoholism ever. Here you look at the proportion of people who are staying under the government limits of 14 units a week. The MDMA group, it's down here, it's 20%, 14%. 14% are above that level. With the treatment as usual, it's about 3/4. So MDMA therapy does a great deal better than standard psychotherapy. And that's why we're trying to set up a clinic in Bristol now to roll it out, because we think it would be potentially life-saving for many, many people. We know that LSD works as well, and it's possible we could resurrect that. The trials of LSD and alcoholism in 1960s, there were 6 trials, they showed LSD has an effect size of 1, which is twice that of any other treatment for alcoholism. And I've estimated in the 50 years that LSD, and certainly the 30 years since MDMA has been banned, over 100 million people worldwide have died prematurely from alcohol use. And if psychedelics and now MDMA could only help 10% of them, that would be 10 million lives saved. Alcohol currently kills 3.5 million people a year. So alcohol killed more people last year than COVID. And we'll do the same this year. And we're denying treatments to people with alcoholism on the completely flawed belief that these drugs are dangerous, used recreationally, which they're not. And even if they were, that's still not justification for denying a treatment, a proven treatment to people, just because you have effectively a moral opposition to the use of psychedelics and MDMA. And that is essentially what we're doing. It's one of the most immoral stances that the UN has ever taken. So what do we need to do now? Well, we need to do more research. COVID is going to drive up depression and PTSD. Half of all people who work in intensive care in COVID, for treating COVID patients, have got PTSD now. Not surprising, because they're facing a disorder they don't know anything about, often without any of the right kind of equipment. So their lives have been put at risk every day they go to work. But working on these drugs, as I've said, is very difficult. They're all controlled drugs of Schedule 1. So what we need to do is reschedule. And I want the ACMD, I want drug science, and I want the Royal College of Psychiatrists to push for rescheduling. And I want you, those of you who are junior members of the Royal College, those of you who are part of this organization, the Psychiatry Student, I want you to push. There is no moral or health or any kind of reason these drugs should not be allowed as medicines. So please help us campaign to get it changed. I'm going to finish with this quote from George Bernard Shaw, the great philosopher and playwright. Those who cannot change their minds cannot change anything. I doubt if I'd change your minds, because I suspect you already had open minds and were interested in what I was going to say and probably had some knowledge of it. But please use the data I presented to you to change the minds of your teachers, your mentors, the Royal College, and also your parents and anyone else that you can change the mind of, because we've got to change the minds of our politicians, and that will only happen when they see that the public's mind is changing. So thank you. Thanks to all the people that helped me do this research, particularly the Alexander Mosley Charitable Trust. It funded the depression study and the alcohol study. And if you want to read more, read my autobiography. It's just come out, and it's got all the details in there about our research, our psychedelic and MDMA research. And all the proceeds go to my charity, Drug Science, which is the only place in the world, I think, you can find out the truth about drugs. Thank you.
Brilliant. Thank you so much, Professor Nutt. That's an absolutely amazing talk. So we've got quite a few questions that have already come in.
Fire away.
So what I'm also going to ask is, if people do want to ask the questions directly, if you raise your hand, then I can unmute you. But I'll just start with some of the questions in the chat.
That'll be quickest. Yeah, go on.
Yeah, that's fine. And just make everyone aware, Professor Nutt needs to leave at 7:30. Okay, so the first question is from Charlie. How long do you think until we see these medications as an option for patients? Well,
I'm hoping we can get the Schedule 1 status reversed for psilocybin and MDMA in the next 2 or 3 years. And I'm hoping to do it before the trials, the multi-center trials are coming out, because I don't think we actually need to wait for that. I think we should allow doctors that are interested and are prepared to go through the bureaucracy. Even if it was Schedule 2, it'd still be a huge bureaucracy to work with them, but at least we could work with them on a compassionate basis. So I'm lobbying government now, I'm hoping in 2 or 3 years, but what we really need are patients to come forward. And there are a lot of patients out there. They're particularly veterans who are now going to South America or to Spain or to Holland to get either ayahuasca or psilocybin treatments. They should campaign through the military charities to get the law changed. It makes no sense. No one is being protected from harms from MDMA or LSD because, or psilocybin, because these are Schedule 1 drugs. In fact, they're more likely to be harmed because they're taking things that are on the black market. So there's no justification for it at all. Hello? Sorry, you've frozen. Can you still hear me? Hello? Uh-huh. You have gone dead. Can you hear me?
Hi, sorry. Yeah, I think Medin just his screen just froze. I'm sorry about that. I think he'll be joining shortly.
I'm back.
Oh, okay, you're back.
Apologies about that. Thank you for answering that. I think Amir had a question. Amir, I'm going to ask to unmute you.
Thank you very much. Thank you so much, Professor Nutt, for that talk. In your campaign for making psychedelics a bit more normalized in medicine, have you heard of what's the most challenging anti-psychedelic argument you've heard being used, and what's your response to that? Yeah,
there are two arguments. There's the sort of moral right argument, the Puritans who say it's immoral. And that's not, of course, not a strong argument, but it's not an argument at all. It's a position statement, but it actually, because there's a lot of them, and the newspapers, many newspapers support that. That's perhaps the biggest hurdle. And then the other one in the medical profession is say, well, there's not enough trials. And I say, well, 6 trials of LSD, showing the effect size of 1. What more do you want? Got to have modern trials. Got to have modern trials that are run by pharmaceutical companies. So I said, well, suppose pharmaceutical companies won't do it. Well, we can't have it then. And I think the other argument you'll hear senior doctors say, well, they're called psychosis. Well, the answer is, if you give them to people who've got a predisposition to psychosis, they might make people psychotic and they might make psychosis worse. But we don't do that in the same way as, there are drugs, when people have got comorbid illnesses, we don't give them drugs which they're vulnerable to. So just because there's a possibility that some people respond badly, that's not a justification. And then the amazing argument, people say, well, they're addictive. And I say, well, what do you mean they're addictive? They must be addicted. They're in Schedule 1. I said, they're not addictive at all. They're anti-addictive. No, they must be addicted. They wouldn't be in Schedule 1 if they weren't addictive. The ignorance and the stigma that surrounds the justification. There's been, we've had 50 years of lying about the harms of these drugs. A lot of people have actually believed those genuinely. A lot of doctors genuinely believe the lies. They don't know their lies, so they perpetuate them.
Brilliant, thank you. So the next question is from Zach. So he asks, do you think psychedelics have a place in the treatment of personality disorders? What are your thoughts on MDMA in this regard, or psilocybin therapy?
Now, that's a really interesting question, because we now have data. Well, we don't have trial data, but one of the things that Robin Carhart-Harris has been very effective at doing is collecting naturalistic data from people who are going on retreats, who are going, for therapy, either with ayahuasca or with psilocybin in the Netherlands. And we've been looking at the data recently, and actually the group that does very badly, the only group that actually does badly, are people with personality disorders. So if people self-report personality disorder, they generally don't have any useful response. Whereas the people who report depression, they do get a benefit in their mood, even if they're not having the psilocybin in a formal setting. MDMA might be different. Don't have any data on that at all at present.
Perfect. Okay, so the next question is from Kale. So I think Kale has two questions, but I'll ask the first one first. Do you think it's a sensible idea to pursue a career in psychotherapy with the overall aim of being able to use psychedelic assisted therapy with patients? Do you think this is feasible in the tangible future?
Oh, I do want you to, because I believe this is going to be a revolution in psychiatry and clinical psychology. And the limiting factor is not going to be the availability of the mushrooms or the psilocybin. It's going to be the availability of therapists. And actually, we're going to be, and I'm really, really keen. There's lots of psychiatrists interested, because psychiatrists realize that actually, when you get to the extreme, the tough end, the most difficult cases of depression, they're very hard to treat. A lot of psychologists don't see those. But so psychiatrists know that we need more tools in our toolbox to treat severe depression and addiction, etc. But we need psychologists to be a part of the therapeutic team as well, because I think the real adventure now is going to be using the combination of psychopharmacology, the drugs, and optimizing psychotherapy. And psychologists are going to be good at that. And I hope we're going to be training hundreds of psychologists to be psychedelic psychotherapists over the next 10 years. So please hang in, please try to get trained. I don't quite know how we're going to do it, but we're working on it.
Brilliant.
Follow us. Follow me on Twitter.
And follow BL Psychotalk as well on Twitter. Okay, a question for myself actually. So you mentioned that the psilocybin treatment was £1,500. Is that just the psilocybin itself, or does that also include the therapist and the other costs as well?
That was the cost of getting the drug through all the ritual. I mean, so no, there was a, yes, I mean, the cost of the therapy on top of that is about, each patient costs about £20,000. And this is going to be one of the really interesting challenges. It may well be that NICE won't approve this therapy. They'll say, well, you can give an SSRI and it's like £1 a week. Why should we spend £20,000 when we can get people undepressed for 200 quid? And they will say that. And people say, well, I mean, and I'll say, well, SSRI is good and they don't work as well and they work in different ways and they have side effects. And I'll say, well, tough. So it's going to be a big, the battle, even if we show that this is a powerful treatment for resistant depression, they're still going to people are going to want to block it on the grounds of the fact it's labor intensive, etc. And we're thinking about ways of reducing the cost, maybe only having one therapist in the session instead of two. Some people are talking about group therapy, having maybe 6 people together with 2 therapists. That might work. I mean, I think the key thing is, I don't think you can have group integration. Afterwards, you have to have the debriefing sessions. I think those need to be individualized, but there may be ways of reducing the costs.
Okay, perfect. And the next question is from Agata. Hi, do you believe that the recreational use of psychedelics should/will be permitted in the future?
I don't like the term recreational use. My knowledge of and all the research we've done on people using psychedelics outside of the medical setting tells us that they're not using it generally for fun. Very few people use it. Most people use it because they're interested in exploring the capacity of their mind. They're interested in unshackling their mind from their brain, and and actually becoming wiser, more interesting, more insightful people. So I don't like recreational use, but if you might say non-medical use, that's going to be a lot harder to achieve than medical use. I think the way forward would be certainly I'd like to see decriminalization of certainly of the mushrooms. Like Oregon has decriminalized mushrooms, and so has Oakland, and so now has Edmonton in Canada. So I think over time people will just become less concerned. I mean, mushrooms truly are one of the, on our assessment of drug harms, mushrooms were the least harmful drugs of all. There's absolutely no reason why they should be controlled. And they weren't controlled, of course, until 2005. They were controlled in 2005 because the Tory party, who at that time were in opposition, decided to attack the Labour Party as being soft on drugs because they allowed freeze-dried mushrooms to be sold in Camden. And Tony Blair decided he was going to be harder on drugs than the Tories because he was getting re-elected, and so he made them a Class A drug. They went from being a legal mushroom to a Class A drug overnight. It was the most despicable political act in terms of drug policy. Probably has ever. Oh, certainly, it's only been exceeded by the Psychoactive Substances Act, which bans everything.
Does sound like it's a lot of a political game as well as a medicinal one as well, isn't it?
All the drug laws are politically driven. All completely. That's why you got to read it's there, read my autobiography. It's all about drug policy. 95% of drug policy is about politics, and it always has been.
Okay, so the next question is from Jacqueline. So people report a positive psychedelic hangover effect. Is this due to the decreased cortical activity you found continuing for a period of days after psychedelic use?
Yeah, it's a great question. Yeah, so they call it afterglow, and not everyone gets it. But people who have very interesting and positive trips often do find it continues, and I know it can last for the rest of your life. People can have a more positive outlook. We've shown that people become more connected to nature, to other people, that they have a sense of well-being, which can last for a very long time. And the positive memories of a positive trip will be with you forever. As Roland Griffiths showed, his patients are now, or subjects are now 10 years on. What's it due to? So yeah, the afterglow is due to a significant, the brain stays more open the next day. That's a simple explanation. It stays more
open. So a question from Frank. Is there a risk for damage to occur in the amygdala/hippocampus with long-term MDMA consumption due to persistent decreased blood flow?
Really interesting question. So I think yes. If you were taking MDMA, if you're taking every day for a long time, it's likely to have some negative effects on the brain in the same way as alcohol has negative effects. The way we're using it is we're using 2 treatments and we're curing people. So we're absolutely comfortable. There won't be any negative enduring. There are clearly positive enduring effects. But it is possible if you took it daily and every day, and you could actually have some negative effects. So very few people do that, of course, but which is good.
So I know with LSD, if you took it every day, you would build a tolerance up to it. Is it the same with MDMA?
No, it's not. To some extent it is, but there is some tolerance, but it's not as complete. With LSD, the tolerance builds up almost completely within 3 days. Do you know how we know that? The American military, they were concerned, they were trying to develop LSD as a weapon of war, and they were worried that the Russians were going to spray them with. So they did these studies to find out, what happens if you keep giving people LSD. And they discovered that within 3 days that there's almost complete tolerance. And that is why it's not addictive, because that tolerance you cannot overcome by taking more.
Okay. Brilliant. So the question from a medical student. So as medical students, how can we contribute to the work of yourself and others in changing the medical profession's stance on psychedelics, and also bringing about change in the law and making psychedelic treatment a mainstream part of psychiatry?
Great question. So there are a few things you can do. Follow me on Twitter, follow Drug Science on Twitter, obviously follow the Psychiatry Society if you're going to be a psychiatrist. That's the first thing. Drug Science has student chapters. So, and in fact, Barts has a Drug Science student chapter. So you can sign up to that student chapter, and that will then get you into the processes of helping drug science do research, do thinking, do lobbying. That's the first thing. The second thing is buy my book and give it to your parents, so that they know when you're talking about these drugs as being the future, they know that you're not gone mad. You know, they reassure them that, you know, I am a proper professor at a rather prestigious university, and what I'm saying is evidence-based. And then, you know, ask all your teachers, and it's not just psychiatry. In neurology, there's psychedelics. We're setting up a study now to use low-dose, non-psychedelic DMT to treat stroke, because the neuroplasticity, the ability of these drugs to heal the brain, or at least to make the brain develop and adapt. So you know, we also know in neurological disorders like severe recurrent migraines, cluster headaches, they're powerful treatments. You know, studies are going on in pain disorders. These could be a revolution in pain, because again, pain is a syndrome where the brain gets locked into a repetitive way of processing memories of pain, so that the pain becomes ingrained in the brain, and even though there's no peripheral pain. That's why I said this, you know, these drugs will change medicine. There's also, I mean, people are trying them for asthma because they're also anti-inflammatory. You know, it's so challenge all your consultants, and end of life as well. You know, they could. That's why I got interested in the first place. When I was a medical student, the first LSD trials in end of life anxiety showed it was really effective. Aldous Huxley took it to die. When I spoke to my clinical pharmacology professor, he said, "Oh my God, we don't talk about that here." And I thought, well, how ridiculous! Why would you? Because it's illegal. Well, but why wouldn't you talk about something that, you know? I mean, and I've kind of been, you know, banging this drum really all my life. And that's probably a good point to stop, isn't it? Because I've been on my drum a long time. So, and it's 7:30. All right.
Yeah. So apologies to everyone who couldn't get their questions answered. But I believe you had your email on the first slide, which you can find also on our Twitter page. So you can go there to find Professor Nutt's email. But I just want to say again, a massive thank you. If everyone could click on the reactions and give a clap, just so we can.
Thank you very much. It has been lovely. And good luck in all your careers. I really, really look forward to seeing some of you in the flesh when you're looking after me in my dotage.